Hey, okay. Can you hear me now? Cool. A few minutes, we will start soon.
really big now. It's tokenizing.
Hey, we will start in a few minutes, so it's I was muted before. Sorry for the delay. All right, let's go. So this is a mentorship session. We can answer any question here. So you have the Q&A and the chat. If you don't have questions, I'll jump right into level 2. So yesterday we talked about level 1. Now I'll talk about level 2. The idea of level 2 is to build a database. So essentially being able to add people into our DAO, remove updates. So it's we are building like a CRUD system. So CRUD, create, read, update, delete. And essentially we are doing that for the members. So today we will talk about data structures in Motoko. We will talk about hash map. This I was muted. I think not, but I don't know what Zoom is about. Sometimes it's okay. So yeah, in case I was muted, I was saying that today we are working on level. Okay, it's okay now. So yeah, today we are working on level 2, talking about level 2, how to add members to our DAO. So essentially we are building a CRUD system, create, read, update, and delete. And to do that, we will use a hash map. So it's about data structures and how we can, just store basically any type of object into a canister in Motoko. So let's jump right into it. It's chapter 6 and chapter 7 that I will need to talk about. And so, of course, we have different data structures in Motoko. We have array, which I mentioned yesterday. We have buffer, which I also mentioned yesterday. Lists. Lists are interesting. It's a recursive type, but I won't talk about it during the bootcamp. You can read if you want. There is a whole documentation. We will not use it for this week. What we will use this week is hash map and tree map. It's very common data structure that we use a lot in Motoko because it's easy to use and very flexible and also very efficient for a large case, like large scenarios, large numbers of scenario. So let's get into the code. Let's get into main.mo. I don't want to do the level 2 like I did the level 1 yesterday. I think I'll just make an example of how we can use a hash map. So What I will do is make another scenario. So level 2 bis. This is just an example. And I will define a type student that I will try to add to a data structure. So public type student. Yeah, I like this field, those fields. So actually, let me disable Copilot. Oops. Oops. Okay, we'll have to deal with that. So hashmap is also a class, like buffer are a class, and we need the same kind of imports and then like syntax. So actually in the code that I've provided on the repo, we have already imported hashmap. This is exactly like we did with buffer. We import the module and then it comes from the base library, and it's yeah, it's like this. Be careful, it's hash map with like capital M. So it's important to respect the syntax. Once we have that, we can define a variable that will store our students. And so that's exactly like this. So students, hashmap, actually hashmap dot hashmap. So we are importing the hashmap class from the hashmap library. And we need to specify the key and the values. So it's, in this case, it would be text and nat. In our case, it would be principal and student. I will explain what is a principal. Hashmap.hashmap, this is where we define it. So here I'm just specifying the type, and then I'm actually initializing it. And we need 3 parameters. We need the initial capacity, the equal function on the keys, and the hash function on the keys. If you don't know why we need those functions, this is because this is how hash maps are like implemented internally. And I don't want to make like a introduction to hash maps. So probably the best thing is, if you don't know, watch like a video. There are very, very good videos on YouTube that explains how hash map is done. It's the same in Motoko as in C and other languages, of course. So probably the first question that comes to mind is, what is this principal? Because we haven't talked too much about it. So principal is an identity on the IC. So any entity that exists on the internet computer is going to have a principal. Let me see. Yeah, I don't have a good picture, but a canister is going to have a principal because it's an entity. A user is going to have a principal, and any entity from the network is going to have a principal. Actually, DFX. So when you have your identity on DFX, you can do DFX identity. Who am I? I am Seb, and you can see that I can have my principal. So this is my principal. It actually comes from my public and private key. So it's actually a hash of my public key and a few more operations. But yeah, essentially one public key, one principal. And so you will notice that some principal have different formats. For example, this one is 64 characters, 5 characters separated by strings. Yeah, by those little dash. And canister ID. So if I deploy, maybe I will fx deploy in the playgrounds. So my DAO. a canister ID is also in principle, but it's a principle with a different format because it's not a principle of a user, it's a principle of a canister. So this is also a principle ID. That means, but for example, we could have a canister register as a student, like in our scenario. A canister could be a student, could be users also. And so when you have a message, so when you call a function on the IC, you can use this syntax. So public shared caller. So I don't have a good explanation of why we need shared, and then like why we need this shared. But actually, so let me show you. So every time you interact with the IC, it's a message that you send to the network. So you're going to send a message, and this message has a caller associated on it. So message.caller, I could do something like this. Let me show you maybe principle. What is my principle? So here I'm creating a function that essentially I'm calling the function, it will return the identity of the person calling the function. So I will show you. If I call the function from the Candid UI, the Candid UI, you are not authenticated. So it's an anonymous identity. The anonymous identity is basically any person that is not authenticated. So where is it? It's in the, yeah. It always corresponds to this principle, this one. So if you see this somewhere in your code, it means that you essentially are authenticated with the anonymous identity. But if I call this canister, so defx canister playground, call DAO, and I want to call what is my principle? If we call it from defx, as we've seen before, I have this principle that is mine, this is me, and so it should return my identity. So that's how you're going to have like different users, how you're going to authenticate them. And that's why we need principle as a key. And it's probably the key that is the most used on the IC. Like most of the time we will use principle for most operations because that's easy like authentication system. And so essentially, yeah, the message, the message contains other information, like basically the message contains the function that you're calling, if you have any arguments. But from this object here, we only have access to one information, that is the caller. So essentially, it's the same if you can destructure the message and just get the caller like this. So I usually prefer this syntax. Both are correct. The message and then message.caller, or just you destructure the message and you just get the caller. I think it makes more sense like this. So I usually use this one. Okay, so now that we have this identity, what we can do is add a student. So we can use the syntax that we have, add students. And essentially how you would do that, you would first need to check if there is a student that is in the data structure. If that's the case, so that's here. If that's the case, yeah, maybe like the other way around would be better. So okay, this is switch case with the optional type is going to be super used in Motoko. So here, essentially we get the students.get is going to be the hashmap function that is here. So hashmap.get. We we put a key, so we put a principal, in this case the caller. It will return a value, optional value. So optional is essentially saying that if there is a student corresponding to this principal, you return the students. If there is not, you just return null. And we can do a switch case on both cases. So this is the case where there is already a student. In that case, maybe we want to return an error that says you are already registered here. You cannot have multiple student profiles for one identity. But in the case of null, so if there is not students registered, we can do students.put. And students.put corresponds to hashmap.put. You specify the key and the value. It will overwrite if there are already a field, it will overwrite any existing entry. And so if we do that, it's add students. Okay, so it's up there. I don't see it. Oh, I didn't save. Okay, so okay, let's see. We should have the add student method now. So we will specify an age. Let's say and so the first time, remember that we are calling with the anonymous identity. So this should work. But if we are trying a second time, we are already registered, so we have this error. And that gives me maybe, yeah, the opportunity to talk about results, which is very important in Motoko. Like just use every time you have a function that you might have a good case and a bad case, you want to use that. So it's essentially a variant type. So variant type are also very important in Motoko. That's how you define a variant type. So you have different fields, in this case, OK and error. And basically the result is the variant type that has two variants, OK and error. And those OK and error, they can also have their own type. So like that's how it's explained here. Like the OK can have the OK type and the error can have the error type. I think it's better to look at an example. So essentially in this case, the type of our OK is unit type. So unit type is no type. And the type of the error is a text, because if we have an error here, we want to return a text inside the error. If we have a OK, we want to return, nothing, just OK, because it's clear that we add the student and that's it. So we couldn't do something like you have successfully, oops, you have registered successfully, because this is not of type unit, this is of type text. If we want to do that, we need to change the type of our result. So yeah. And in general, it's very, very recommended to use results, because it's very good to be able to, for the person calling the method, you can use a switch case on the other side. So imagine that someone else is calling your add student. They can do a switch, and they can do, if I receive OK, then I do this. If I receive error, then I do another thing. So it's really good because you give information about what's happening to the person calling you. There are other ways to like handle error with Motoko. For example, there is a concept of trapping. There is a concept of rejecting messages, but it's very, very recommended to use this if you can. So that gives me the opportunity to talk about variants. A variant is a type with different cases, very used as well in Motoko because variance goes closely with switch case. And so a good example is usually a vehicle. You could have a vehicle that is a car, moto, or plane. And as I said, each variant can be associated with its own type. So you can have a custom type car, a custom type moto, custom type plane. And then that's how you would define a vehicle. And then you could have a function that could take any vehicle and start this vehicle. If it's a car, it's going to be vroom. If it's a moto, it's going to be roar. If it's a plane, it's going to be whoosh. And so that's how you could use the variant type. Another good example would be like days of the week or something similar. So we have everything we need to add students. Then for the rest, like update students, delete students, show students, it's going to be a similar pattern. So you will use this color and you will find the methods that you need in the hash map documentation. So we have the size, we have the get, the put, replace, and delete. Yeah, I think that's what you need. And we've talked about the result, we've talked about the optional type. Yeah, optional type is very important. So that's essentially that's defined in the chapter 6. No, in the chapter 7 actually. No, strange. Oh yeah, it's defined here. So optional type, it's very important also in Motoko. So that's gonna be any type can be optional, like can have its optional version. So optional night is gonna be like this. Optional text is gonna be like this, and essentially this is like an equivalent to text or null, and same format. Generic type as well is something that we have seen, but I haven't really explained it. But it's essentially in the documentation they use it a lot. Generic is just a way to handle any type. So for example, I think there is an example in the level 3 actually, because I'm defining some type. And no, it's not here. Is it here? That was level 4. Where is level 4? Ah, yeah, it's level 4. It's here. No, it's level 2 that I was looking for actually. So yeah, this is where I use the generic. I want to essentially, what I want to do here is having a way for, actually this is like not necessary, but yeah, it's not necessary. So I won't talk about it. And so this, I think that's approximately everything you need for level 2. Maybe there is a question. There are some questions in the chat. I haven't been able to answer it. What is it? Yeah, okay, I will address the chat. When working on local or code space, how is the canister updated when you change the code? So yeah, you need to redo like every time a defx deploy playgrounds. I've seen other people. So if you're working locally, if you have a local replica, but I didn't want to talk about that. So you can have a local replica, it's good as well. The problem with this, for the people that are using the code space, like your local replica is going to be on the local code space and you don't really have access to, because it's going to be like, so yeah. If you're using code space, always deploy with the playground. It's easier. It works. You can access and you can also send your interface to anyone. So it's easy to verify. But if you are working locally, you could also do, you could do a deploy, just simple deploy. So this is locally. This is playgrounds. And this is real internet computer deployment. And every time you save your file, you need to do a redeployment. We don't have the concept of live server yet. So yeah, you essentially need to redeploy when you want to test something. Can you explain the color? I did not get that. So yeah, the color is the person calling the function. So it's the identity of the person, because every message on the IC is actually composed of maybe we could see that message. Like, no, it's not this. I think there was a really good article. Okay, I don't find it, but there is like every time you interact with the IC, it's a message. That's actually what I talk about in chapter 1. You're essentially sending a message to the canister, and this message is composed of function that you're calling, arguments of this function, and who is calling. So you have a signature, basically. Kind of like when you do a transaction on like Bitcoin or Ethereum, you have to sign transactions. It's the same. And essentially, it gives you the public key of the person calling. So the caller, like you directly have access to who is calling your function. This is how things work. And so this is how you get this information in Motoko. And so this is a principal. Principal is the type for identities. Principal. Of course, there is a module associated with principal. Principals are used to identify entities that can interact with the internet computer. These entities are either users or canisters. In Motoko, there is a primitive principal type called principal. So yeah, and a principal can be converted to a blob, so bytes representation, a text. You can check if someone is anonymous. You can check if someone is the controller of a canister. You can hash the principal, and so on. What is the difference between hashmap and treemap? When do you recommend each one? So hashmap and treemap, they have the same interface, which is really good because essentially everything that we're doing, like .gets, .puts, it's the same for hashmap and treemap. When use each is it's going to depend on the operations that you do. I don't have a perfect answer. I think there are some benchmark, but it's really, really like optimization at this point. So essentially, I think treemap generally are a bit more efficient from what I've read. But it will not matter that much for what we're doing. Of course, if you are doing like a large scale project, then you might run into like optimization. And then that's how you look into, is a hashmap more efficient than a treemap and so on. So it's essentially, it's how the underlying memory layout and how the data structure is done that is different, but the interface is the same. And yeah. Shared versus public. Yeah, so shared, it's just a keyword that you have to put. Actually, it doesn't make a lot of sense because any public function is a shared function. Well, actually, well, no. Forget about what I said. No, it's not true. It's only true in the body of an actor, but you can have modules. So like, for example, those functions are public, but they are not shared because shared means shared to the like external world, and this is a module, so it's only public because it's going to be imported in main.mo, but not exposed to as an interface. Like if you take a look at my canister, you won't see in the candid UI, you won't see this function, you won't see this function, and so on. So shared is about making it accessible to the outside. But essentially, it's like you have different syntax. So if you do a public query function, is going to be like this. Public update is going to be public func add member. And you only need to add shared when you want to access the color. So when we want to access the color, we do a shared. And if you want to query, like public query shared, that's, oh, wait, either it's like this. Yeah, so those are the 4 syntaxes that you can find in Motoko. The first one is query, normal. Update, normal. Updates where we need to know the color, and query where we need to know the color. Those are like the 4 cases that you will find. There is not other cases, I believe. Yeah.
Is it important? Why is it?
Can I give you this? It's about to shred. Yeah.
Why the order is query func, but shared query, not query shared? Or the same?
Just a convention. I think it comes from like, just, I don't know, honestly. It's just the convention of how the language has been like written. And yeah, it's like public shared query. So basically, like,
oh yes,
yeah.
no, because there's func after, yes.
Yeah, func is always the last for sure.
Okay,
like
yes,
it always
yes,
ends with
yes.
func.
Func is the last.
And so public is always the first. Then you have like shared or not shared,
not.
but
Then query or not.
I always have
Func.
this question, but I don't think there's a good answer, because actually shared is I will actually look and try to come up with an answer for why this shared is here and not like, but it's always like public, shared. Then if you have a query, it's query. If you have a func, it's func.
Yes,
yeah.
okay.
We have like 4 fields. Yeah, you can keep it. Yeah, Motoko grammar. Actually, I think they should. I don't think it's the best like syntax. I think they should have like maybe 4 fields. Like, is it public? Is it shared? Is it query or updates? Is it func? And like always, like for example, I think it would make more sense that we would do this, because we would see the difference. Like, yeah. Just my take on it. I don't get a lot of, yeah. Another question, but not on shared. Oh, can you deploy multiple canisters and interact one with the other like containers? Yeah, so there is this concept of inter-canister call, which we'll see later in the week. You can do inter-canister call, so you can call a canister from your canister. And this is how you like compose services together, which is super cool. You can call any canister as long as you have the interface of it. And it's very easy to do, actually. Just one line. Yeah. You can import a canister like you will import a library, and then you can call it. Why the async instruction? So why do we have this async? And the await on the tests. Yeah, this is because we need to await when we call a function on a canister. async awaits comes from actually JavaScript at the origin. Like this is very common programming concept. Basically, it's the way canisters handle messages. So canister, they are going to imagine that you have a canister and it receives messages corresponding to functions that will be executed. And sometime, if you're calling, for example, another canister, you will use async awaits because you don't get the immediate result. Like you need to wait. Maybe the canister you're calling is doing something else. And so there is a delay. And so async awaits enables you to essentially continue to process messages while you are waiting for the answer of another canister. So it means asynchronous. And yeah, await means that you are going to resume your code. So when you do like an await, you resume the code whenever the canisters has the canister you're calling has sent you the answer. Because I mean, in programming and when we code, instructions execute line by line. But sometimes we are calling another process, and so we need to wait for this process to answer us. And that's why we have async awaits. If you want to read more about that, like I think there is this, yeah, this explanation, but it's also just a general concept, like in programming in general, like async await is not only Motoko. So I think they explain it. We talk about it, the actor model. Each canister is an actor. And well, this is very high level explanation. In Motoko, sending a message to an actor, so if you're calling another canister, it's a function call, but instead of blocking the caller, so when you call another canister, instead of waiting and doing nothing until the other canister has answered you, you will continue your execution, and you have what's called a future that represents the requests. Whenever you wait on the request, you will resume the instructions. Yeah, thank you. Okay, we are on time. So we have in 15 minutes session with entrepreneurship in Web3. So I'm looking forward to this one, and I'll meet you there. See you.